Howdy. Breaking news. Breaking news. Newton's law of universal gravitation is challenged by controversial new astrophysics discovery. October 28, 2022. A team of astrophysicists has revealed an unusual discovery, they say, appears to challenge our current understanding of gravity based on Newton's law of universal gravitation, according to a newly published paper. Yeah, that's not the paper, that's just an article about the paper. The controversial claim, published in the monthly notices of the Royal Astronomical Society, which might be in England, appears to be consistent with alternative interpretations about one physics' most mysterious fundamental interactions. In their new study, an international team of astrophysicists says that they came upon the discovery while investigating open star clusters. These formations are created as a gas cloud emerges following the birth of thousands of stars within a relatively short time, the remnants of which are ejected as these clusters of stars ignite and begin to expand, which can result in the formation of anywhere from several dozen to several thousands of new stars. Gravity's role in this process involves how the weak gravitational forces essentially serve as the glue that contains these clusters of stars and holds them together. Now, the weakest of all is the glue. Able to survive for hundreds of millions of years, these clusters do eventually begin to lose stars over time, resulting in the formation of a pair of tidal tails, one of which is dragged behind the open star cluster as it is propelled through space, while the other protrudes ahead of the formation. Based on Newton's law of a universal gravitation, we would expect the process of how various stars in the cluster become allocated into either of these tidal tails to be entirely random. However, that wasn't the case, according to the team involved in the recent study, who found that one of the two tails clearly was able to outperform its star-grabbing counterpart. That's really annoying, this window down here. In the clusters we studied, the front tail always contains significantly more stars nearby to the cluster than the rear tail. According to Dr. Jan Vlam Altenburg, the Helmholtz Institute of Radiation of Nuclear Physics, the front tail always contains significantly more stars than the cluster than the rear tail. This made me thinking, and I tried to imagine this, like front and rear tail. So I took a picture of a fox, and now he has a front and a rear tail. Thank you, Rutgers, New Jersey Agricultural Experiment Station. That's just a coincidence that it was from that page. But it's a thought experiment, and obviously you can see my Photoshop skills are unbeatable. No one ever will notice anything that this picture has been altered in any kind of way. I'm a simple man. I like simple things. So a front and a rear tail just inspired me. And somehow it doesn't look really natural. in a way. But anyway, I'm no doctor, and I'm not working at the Helmholtz Institute of Radiation and Nuclear Physics. So, the asymmetry between the number of stars in the leading and trailing tails tests gravitational theory, the authors wrote in a paper. Tests. In other words, proves it wrong. Dr. Teresa Yerabkova, one of the paper's co-authors, says that the research team was the first to develop the method they use to calculate the number of stars that become allocated within the pair of tidal tails in star clusters. Tidal tails. When we analyzed all the data, we encountered a contradiction with the current theory. Yeah, probably many. Yerabkova said in a statement, adding that the level of precision of the data the team had available to them in survey the data from the ESA's pioneering Gaia mission had been indispensable in making their observations. If not a traditionally accepted Newtonian concept of gravity, then what did this new contradictory data seem to point to regarding the weakest of the four fundamental forces? Yeah. How much does it take to overpower the weakest of all forces? Probably not much. I don't know. I'm still thinking about the fox. The research team believes that a theory of gravity involving what is appropriately known as modified Newtonian dynamics. I didn't make it further until to the two tails, and I thought about foxes, and now this Mond comes again. May I offer the answer? Mond proponents argue that observations of galaxies and their properties point to the necessity for modifications to Newton's law of universal gravitation. Significantly, such ideas could potentially resolve problems like the question of dark matter by offering alternative models to account for the behavior of galaxies and the weather on Earth. Our history as humans, probably also medicine stuff, where is our consciousness located and stuff like that. Which in many instances do not appear to obey the laws of physics as we currently understand them. Which in many instances do not, yes, let's try again, do not appear to obey the laws of physics as currently understand them. Yeah, it's just a matter of who you ask. Put simply, according to Mond, stars can leave a cluster through two different doors, says Pavel Kroupa, the study's lead author, who added that where one door leads to the forward-facing tidal tail, the other to the one behind the cluster. Yeah, I forgot to draw a door to the fox. However, as Kroupa notes, this first is much narrower than the second, so it's less likely that the star will leave the cluster through it. Newton's theory of gravity, on the other hand, predicts that both doors should be the same width, Kroupa says. Although team members expressed that current tools available to physicists that may help them analyze potential modifications required to Newtonian dynamics are limited, no, they aren't. If even now I know about them, I could send them many links. Calculations based on simulations nonetheless appear to be able to accurately predict the lifespan of open star clusters. If your theory is not able to predict, it's wrong, since it's not even able to explain what's happening right now. This, according to the research team, is much shorter than what Newton's laws would seem to allow, and for Kroupa and her team, this might even explain the mystery of why star clusters and galaxies nearby to ours have been observed disappearing more quickly than astronomers expect, because they don't understand redshift. Naturally, theories that require significant changes to our existing models of how the universe works are generally slow to win favor among scientists. Yes, because they run into a wall of ignorance. There are many, many scientists who don't know that they don't know, that they aren't scientists, they are scientismists. They are working within the paradigm which leaves them no chance to look outside of their own paradigm. If they would do, they would lose their job because there would no money coming in anymore for the reasons they are making the work, because they are keeping up the mysteries. They make a living out of it. But anyway, yeah, of how the universe works are generally slow to win favor among scientists because of ignorance. It's that simple. Much, not everything, much of modern science is more a religion or a business than open-minded people searching for truth, no matter in their own beliefs, because they want to know the truth. That's something really different than following some business plan and spending billions of dollars for some CERN machine which won't find anything. And the scientists at CERN, they need so much electricity you cannot imagine. But the rest of the population, they have to be scared about it. Like, do we have electricity at all? How expensive will it be? And those others are just using it for searching something which doesn't exist. Modifications to Newton's theory of gravity, while useful in helping resolve such observations as those entailed in the team's recent study, will also have wider implications that could potentially extend into virtually all areas of physics. But for Kruoppa and her team, accepting and incorporating such ideas into our knowledge of the universe would be more helpful overall than anything else. It solves many of the problems that cosmology faces today, Kruoppa says. The team's paper, asymmetrical titled Tales of Open Star Clusters, Stars Crossing Their Clusters, Challenge Newtonian Gravitation, was published in Monthly Notice of the Royal Astronomical Society. Let me share you something quickly. Yeah, the fox popped in. Donald E. Scott. This is a man everyone who is interested about space or whatsoever. Everyone who is curious. Everyone who wants to know and not to believe should listen to Donald E. Scott. Because if you are living in a paradigm which is based on belief, it will fall apart in the moment you stop believing it. But if you're searching for truth, it doesn't matter if you believe in it or not, because it will relieve, or what is it, the word? It will show itself sooner or later. It will persist and will stand on its own feet. It doesn't have to be defended ever, because it is how it is. But now let's have a quick listen to him.
Double layers here. There's an outer layer and an inner layer here and here. See it out there. See it.
Yeah, a front tail and a back tail, or what?
You can see that the strongest current is in here because these things, these white globs, are are double layers. This is a perfect, in my mind, and I think in many of our minds, perfect representation of. Dave Tabbitt loves the word archetype. This is an archetype, or if you're an engineer, prototype. This is the basic model. They're all are these Z pinches are all variants of that, and we'll come back and talk about some of those properties. And I would say I'll speak for Wall. I'm pretty sure he agrees with me, and I and some others believe that that's the way stars get formed. What you're looking at there is not the death of a star, which is what a professional astronomer at least used to call it. They're getting off of that now. I've actually heard one say that's the birth of a star. You got it. That's the birth of a star. Because when that thing pinches together, that bright object in the middle is condensing. It's not dying, it's not dissipating. So we think that that's how our sun was created.
And I really recommend to everyone listen to him. Probably much better than listen to me. But anyway, I leave it here. And there a few days ago I saw a really big fox, which was very interesting. Thanks.